discuss about the goodness of fit test equal expected frequencies.
Goodness of fit test equal expected frequencies. So the idea behind the chi-square goodness of fit test is to see if the sample comes from the population with the claimed distribution. Another way of looking at that is to ask if the frequency distribution fits a specific pattern. So two values are involved. First one is the observed value, which is the frequency of a category from a sample. And the other one is the expected frequency, which is calculated based upon the claimed distribution. So, expected frequency because the frequency is expected to be the same for each category or the equal frequencies. So, the derivation of the formula is very similar to that of the variance, which was done by the other reporter. The idea is that if the observed frequency is really close to the claimed or the expected frequency, then the square of the deviations will be small. The square of the deviation is divided by the expected frequency to weight frequencies. A difference of 10 may be very significant if 12 was the expected frequency. But a difference of 10 isn't very significant at all if the expected frequency was 1200. And if the sum of these weighted square deviations is small, the observed frequencies are close to the expected frequencies, and there would be no reason to reject the claim that it came from that distribution. Only when the sum is large is the reason to question the distribution. Therefore, chi-square goodness of fit test is always a right-tail test.
So I'm gonna discuss further later on why it is always a right-tail test.
The test statistic has a chi-square distribution when the following assumptions are met. So the first one, the data are obtained from a random sample. The next one, the expected frequency of each category must be at least 5. So this goes back to the requirement that the data be normally distributed. So we are to simulate a multinomial experiment like using a discrete distribution with the goodness of fit test and a continuous distribution. And if each expected frequency is at least 5, then you can use the normal distribution to approximate, much like the binomial. Now let's have the properties of the goodness of fit test. Number 1, the data are the observed frequencies. This means that there is only one data value for each category. Next, the degrees of freedom is 1 less than the number of categories, not 1 less than the sample size. So again, for the degrees of freedom, it should be 1 less than the number of categories. Next, it is always a right-tail test as a chi-square distribution. Next, the value of the test statistic doesn't change if the order of the categories is switched. And the last one, the test statistic is x squared is equal to the summation of the observed minus expected squared over the expected.
So this is the reason why we are always in a right-tail test, because our output here is always positive. And take note, the expected value for each cell needs to be at least 5 in order for you to use these tests. So if our expected value is less than 5, then we cannot use the goodness of fit test.
Now let's have the example. So example number 1. Absenteeism of college students for math classes is a major concern to math instructors because missing class appears to increase the drop rate. So suppose that a study was done to determine if the actual student absenteeism rate follows faculty perception. So the faculty expected that a group of 100 students would miss class according to this figure. So we have here the number of absences per term and the expected number of students. So a random survey across all mathematics courses was then done to determine the actual number, which is our observed value here, of absences in a course. The chart in figure 1.2 displays the results of that survey. So again, we have here in our table the number of absences per term and the actual number of students. Now, our question here is to determine the null and alternative hypothesis needed to conduct a goodness of fit test. So for our null hypothesis, it stated here that student absenteeism fits a faculty perception. So the alternative hypothesis is the opposite of the null hypothesis. So for our alternative, let's say student absenteeism does not fit faculty perception. So question, can we use the information as it appears in the charts to conduct the goodness of fit test? The answer is no. So let's notice that the expected number of absences for the 12 plus entry is less than 5. So it is 2. So let's go back. So here, for our 12 plus, the expected number of students is 2. So
Since the definition stated that our expected value should be at least 5, then we cannot conduct goodness of fit test for this example.
So in order for us to conduct goodness of fit test, we need to combine that group with the 9 to 11 group to create new tables where the number of students for each entry are at least 5. The new results are in figure 2.1 and figure 2.2. So here, as you can see, so we have number of absences per term and the expected number, and we have also the actual number of students.
So using these tables, we can already conduct a goodness of fit test because our expected values here are greater than 5.
For our next question, what is the number of degrees of freedom? So since there are four cells or categories in each of the new tables, so our formula is number of cells minus 1. So since we have here 4, 1, 2, 3, 4, then 4 minus 1 is equal to 3. So our degrees of freedom here for this problem is 3. Now let's proceed to the next example. So employers want to know which days of the week employees are absent in a 5-day work week. So most employers would like to believe that employees are absent equally during the week. So suppose a random sample of 60 managers were asked to which day of the week they had the highest number of employee absences. So the results are distributed as in the figure. So for the population of the employees, do the days for the highest number of absences occur with equal frequencies during a 5-day work week? So let's test at a 5% significance level. So here we have the number of absences for Monday, Tuesday, up to Friday. So our null hypothesis and alternative hypothesis here are, for our null, the absent days occur with equal frequencies. That is, they fit a uniform distribution. And for our alternative, which is the opposite, the absent days occur with unequal frequency. That is, they do not fit a uniform distribution. Now, if the absent days occur with equal frequencies, then Out of 60 absent days, the total in the sample 15 plus 12 plus 9 plus 9 plus 15 is equal to 60. So there would be 12 absences on Monday, 12 on Tuesday, 12 on Wednesday, 12 on Thursday, and 12 on Friday for our expected frequency. So let's just divide 60 divided by 5. So 12 each. So these numbers are the expected, or our expected values. So the values in the table are the observed values or data. So this one, this 15, 12, 9, 9, and 15, that is our observed values. So this time, let's calculate our test statistic by hand. So make a chart with the following headings and fill in the columns. So what I did is I made a table for the difference of the observed minus expected, and their squared, the squared of their difference, and the observed minus expected squared divided by the expected. So 15 minus 12 is 3, 12 minus 12 is 0, 9 minus 12 is negative 3, 9 minus 12 is negative 3, and 15 minus 12 is 3. So if we square these answers, we can have 9999. These answers will be divided by the expected. Then we can have these answers, the 0.75, 00, 0.75, and 0.75.
Their summation is 3. So now we already have the test statistic, which is 3.
Now to find the p-value, we can use a Microsoft Excel in finding the p-value.
You can use your laptop or computer to find the p-value. So I am using here the Microsoft Excel, the 2016 version. So we can also use this Excel in order to find the summation of the number of absences, the expected values, and the chi-squared test statistics. So in finding the p-value, all you have to do is to type equal sign in the word chi. So we have here a lot of options. So now let's choose the option 2 since we're in a right-tailed test. So just click the second option. Okay, so after we click the second option, we have here a suggestion for our test statistic, which is x and the degrees of freedom. So let's input our test statistic here, which is 3. Okay, and then comma, and our degrees of freedom, which is 5 minus 1 is equal to 4. So let's input 4 here. And then close parentheses. And then enter. So there you have it. Our p-value is 0.5578254. Check if our answer is correct. So as we can see, our p-value here is 0.5578. So our solution in the Excel is correct.
Our degrees of freedom here are 4. So next, let's complete a graph like the following one with the proper labeling and shading. So we should shade the right part of our curve. So since we have test statistic, which is 3, now from 3 to the right, then let us shade that one. And for with including the p-value here, because that is the area of the shaded part. So that's the importance of our p-value here. So our area is 0.5578, which is our p-value.
And aside from the p-value, which is the area of the shaded part, it is also our basis in making our decision. And the decision for this is not to reject the null hypothesis. It is because it is stated here that if the level of significance is less than the p-value, then we should not reject the null hypothesis. However, if the level of significance is greater than the p-value, then we should reject the null hypothesis. And for this problem, we can see that our level of significance is 0.05 and our p-value here is 0.5578. So therefore, we should not reject the null hypothesis.
So for our conclusion, at a 5% level of significance from the sample data, there is not sufficient evidence to conclude that the absent days do not occur with the equal frequencies.
So I have two assessments here that you need to answer in order to measure if you really understand and learn from my topic. So number 2, so you just have to answer this following. Alright, so that's the end of my topic. I hope you learn a lot. Thank you and God bless.